variables, the chance of your variables becomes significant going less. Because when you add the variable to the framework, the type coefficient of the other type coefficient is going down. So the chance of becomes significant. So this is the reason we mostly mention that this avoid to develop very, very, very complicated model. When you take 10, 12, 15 variables in the same framework, at the end, 5 or 6 of them is at least become insignificant, and the reason is because your framework is very complicated, and each variable you add, the path coefficient, the effect of other variable is going less. So the model, when you develop the model, you should consider this factor also, and the things that when the times that the variable is so much, you try to select the variable that is the most important ones, or if you don't consider, or you try to merge some variable and make one or two variables. So there is also a method to do that try to discuss it. So any question on control variable or type of variable
or PhD, what is the minimum variable then?
Actually, yesterday also we discussed it here. I say for PhD, even the number of objectives, even the number of variables, not important. The most important thing is the PhD, the meaning of PhD is in one gap, a good gap in the literature. You can have, maybe in the framework, you have more than 10 variables, but at the end, you just replicate the previous studies and you don't fit any gap. So this one you won't consider as a PhD. But sometimes I saw the framework even with the only 4 variables, but really have a very good gap in the literature. So that one we consider as a PhD. So if I want to compare the PhD and the master, in the master, most of the time the students only take one theory and apply that theory, and not any new innovation you can see, anything of the gap in the studies. But in the PhD, we expected to find the gap and you fill up the gap and don't care about the number of pages of it. Because I saw the thesis with only 130 pages, but really value to publish, and we published 5 papers from this thesis. But so this is more than 300 pages, at the end it's nothing. So the number of pages, the number of hypotheses, the number of variables, don't care. The most important thing is what is the gap, what we want to fill up. So these are the variables, and now we will move to the analysis. We see how we can analyze this type of models. So the PLS, the structural equation modeling, the regression is useful to analyze this type of model. But we have other type of analysis that using when you want to compare, for example, the mean of two variables. For example, you want to see that the mean of some factor is difference between two groups. That one we call test on over and other type of test, and we are not going to cover it here. And PLS is only going to test the effect of some variable on another. So we have 4 or 5 variables together, and we want to see the effect of this variable on other variables. So just before I'm starting to discuss on the PowerPoint, I'm going to show some of the papers that we publish and we use the moderator and at the same time mediator or something like that, and we use PLS for analysis. So this is one of the model We want to see the effects of cargo management, facility management, human resource management, and information management on supply chain security operational performance. And security culture is the moderator. So I believe that in develop the new things, one of the things that can be used is moderator. In this paper is published in one Q1 journals, and the only thing that is new in this framework is the moderator. They publish only because of this. All of this will be duplicated. And they just interested to see the moderator in this framework, and they say this type of moderator is new. And if you want, I can also show you the reviewer comments. And all of the three reviewers review this paper, and all of them only focus on the moderator. So one of them is moderator. This is the paper that we published in Transportation Party. And if you see here, the model is very simple. We don't have any mediator, any moderator. The model is very, very simple model, but it's published in the Elsevier journal. And the reason is only the gap that we recognize here. The gap here is we just look at the one study that is published in the very high rank journal that is already published by others. In that others, they're talking about public transportation. And they say that majority of previous studies say public transportation have some factor will be effect on customer to use public transportation. But the public transportation have different types. We have bus, we have train, and we have different type of public transportation. And they say that the factor for each type of public transportation is supposed to be different. So they just use the same model, and they show that for using bus, the factors that is important is different from the factor that when we use train. So I'm thinking I can do the same way, but the people that using public transportation, they're going to, some of them going to job, going to the work. Some of them going to shopping mall, and some of them is going to the vacation. So the people that is going, the purpose of traveling is different. So I try to show that the factors is different based on the purpose of travel. So at the end, I analyze the model 3 times. And I show that, you see, some factors is different when they're going to shopping center, they're going to other purpose, and the factor that is become significance between them is in some cases different. So this is the reason and there is no study that already doing this type of comparison between the aim of traveling. So because of just the gap, you're interested. And another one is the last one that I want to show is also is published in tourism management. And this one is also the things is we just talking about mostly medical tourist satisfaction. We're talking about Islamic medical tourism, and Islamic word in the medical tourism is a new term. So still the gap in the Islamic medical tourism is so much. If somebody is interested, you can work on the Islamic medical tourism. There are many studies on medical tourism, but on Islamic medical tourism, we have few studies. It means that the people that travel to Malaysia, because in the hospital of Malaysia, we practice Islam. Islamic way we practice. So they travel here for medical purpose only because of the reason that Malaysia is Islamic country and they practice Islamic practices. So we see that the doctor practice halal, the nurse practice halal, and the hospital practice halal. It's effect on them to travel to Malaysia. So expected that we going to analyze at the end of this lecture, we can analyze this type of frameworks. So we move to theoretical part, and first of all is we have a structural equation modeling we call SEM. So uh, the first things we need to know that why we need to use SEM, and many of you that working in social science, you are familiar with the MOS, SPSS, and we want to see why we, in the regression, from the regression, we move to PLS and we move to CBSEM. CBSEM is MOS, and PLSM is PLS that we use today. So both of them we call a structural equation modeling. PLSM and CBSEM. CBSEM, the software that we use is MOS. So, and the PLSM and CBSEM we call the second generation. So, but there is some difference between these two software, and this one is mostly going to confirm some things. This one is using to explore new things. If you want later, we can share the PowerPoint. Yes, we will email the PowerPoint. So, first of all, we need to know why we use a structural equation modeling. One of the reasons is measurement error. When you give the questionnaire to some people, when you post the questionnaire, they fill out the questionnaire. Many factors can be effect on them. Even if the place is noisy, maybe the answer is different if the place there is no noise in that place. Even so, maybe I'm the person that is going to answer my questionnaire will be in rush. So this one also will be effect on the answers. And if you want to, if I want to do that, I will tell you today you give one question to one person. Tomorrow you give the same question to the same person. Definitely the answer is different. So it means error is existent even in the when you fill out the question. So one of the use of PLSM and CBSM is they can control, they have some method to minimize this type of error. But in regression that we use in the PLS, we cannot minimize this error. This is one of the reasons that we move to a structural equation modeling. Another thing is observed variable and unobserved variable. When you have one variable, brand image, you have, for example, 4 items, item 1, you have 4 items to measure brand image. In the regression, we have the value for this 4 items, and if we want to later do the regression analysis, I need to take the mean of this 4 and put as the value of this variable. But this one have many errors if I take in the mean. Very simple things. If one respondent's answer 3, 3, 3, mean is become 3. The mean. If one respondent answer 1, 3, 5, also the mean is 3. Is it 1 and 5 is similar to 3? No. This one is neutral, neutral, neutral. This one is strongly disagreed. As in another item is neutral and is strongly agreed. So we cannot consider these two persons as the same result. But if we want to do regression, as regression, take the mean, take, in the regression, consider these two same. We, we, we analyze them as the same person, they giving the same answer. But in the PLS, this one we call unobserved variable. And this one is the observed. Observed, it means that I can measure. I give the questionnaire, they will answer. But the variable is not, they won't be answered directly to the variable. So variable is unobserved. But the PLS, no need to take the mean. The software can measure itself the value for this variable. And later we will see that the software gives value to the variable. So the error will be less. So this is another reason that we move to PLS and CVSM. But one of the main reasons that we use CVSM, one of the main reasons, you remember we talked about mediator now. If we have mediator in the framework and you want to do regression, you need to run regression 4 times. 1 times IV to MV, 1 times MV to DV, 1 times IV to DV means independent variable to dependent variable, and 1 times IV plus MV to DV. So if I want to analyze this model, if my model is be like this, I want to analyze this one in the SPSS, I need to do it 4 times. 1 times IV to MV without considering the mediator. 1 times IV to MV, 1 times MV to DV, 1 times IV plus MV to DV. So I need to run 4 times. And each time I run the framework, I have 5% error. And I run 4 times and each time 5%. But in the PLS, I run only 1 time. And only 1 times 5%. So you see how the result is more accurate compared to the times that I'm running with the SPSS. So any variable, just this one, we want to confirm with you that you understand that there is the value of minimize zero. Any variable you're going to measure with 3 items, for example, or 4 items, or 5 items, there are some errors. So we say that if you want to measure this item, if the item real value will be A, A will be equal to A1 plus error systematic and plus random error, error random. So we have 2 types of error, and the PLS can be minimized this type of error. So we have these 2 types. This one, the reason that the order of items. You put all of the items of perceived quality in not, sometimes the different design in some person put the 1 item first, and between of the items of perceived quality, they put another item, then again back to the perceived quality. So the respondents cannot answer to the first question, and based on the first answer, we give same answer to our other question. But majority of us, when we want to measure, we put all of the item of perceived quality together. So the respondents read the first item and close the eyes and answer to the other items. So later, when you go to collect data, you will have this experience. Many of your respondents answer to your questionnaire same answer, four, till end. So it doesn't mean that he really thinks that the answer for all of the items is agreed. It means that he closed the eyes and he answered. What we do, if we are in the stage of questionnaire design, sometimes I give some questionnaire in the reverse way. So I expected if you want to answer to this question for, because I put the questionnaire in the reverse way, you need to answer 2. But you see, no, it gives a still 4. So it means that this person we cannot include his answer to my analysis. So I excluded from analysis. There is one rule of thumb. We say that if one of the respondents have the same answer, more than 16 same answer, without changing the answer in between, we need to remove this respondents. So this is the rules of thumb from psychology. So, but the main thing is we know that regression no use anymore. We need to use CBSEM or PLSM. CBSEM is covariance based, PLSM is variance based. But the question is, when we use CBSEM, when we use the PLSM, is it these two software is going to compete together? No. These two software is coming to complete each other. It means that sometimes PLSM should be used, sometimes CBSEM should be used. And we need to know when CBSEM, I will tell again, CBSEM means MOS. The software is MOS. And PLSM is a smart PLS, bulk PLS. We have different software for that. But the question is, when we use PLSM, when we use CBSEM. The PLS, one of the first difference between these two is what is the aim of your study. You want to confirm one theory, or you want to explore new things. In the framework that I show you about halal Islamic medical tourism, definitely the variable that we use is new variable. So nobody is tested previously, and we are going to explore new things. We're coming with new ideas, and we want to see the new factors. So this one definitely we should use PLS, because PLS is coming for exploring new things. But MOS is useful when I have a very, very strong theory, and I want to confirm the theory. For example, theory of TTV, you use the TTV and you want to test the TTV in the new context. But the variable is well established already, and the relationship is already tested by many, many, many researchers. Only the thing that you want to do, you want to confirm that this theory will be worked in your context of the study. So the theories existed, you are not coming with the new variable. This one we need to use CBSEM and use the MOS software, because you are coming to confirm things that is already existing. This is one of the differences. Another thing is PLS need less sample. Sample size is the sample that the data that you need to give to the PLS to analyze is less compared to the MOS. So in some type of a study, collecting data is very difficult. As I told yesterday, when we are doing study on construction, green construction management, only 178 companies in Malaysia that doing green construction management. So if I want to collect the data, I can maximum collect 100 to 110. And 100, 110 data is not enough doing a most. Because a most needs at least 200 above data. So another reason that we are selected using PLS is the number of data that we have. And later, if you want, I can show you, or if you check the papers, in our papers, you need to come with the justification why PLS. And if you are not discussed about why PLS, they will ask you, why do you choose PLS? So, another justification, another things that we need to consider when we want to select between PLS and most is the model is complex model or not. The model, how many variables is in a model? If your model have more than 6 variables, we consider the model is a complex model and definitely we need to use PLS. Even you have a good theory, when the model is very complex model, very, very, very difficult to get model fit the most. So PLS is useful when the number of your variable is more than 6 or the number of items is more than 60. So these are the rule of thumbs. If we have the reference on them, I'm not telling from my own. So Shin say that if the model is more than 10, if the number of items is more than 6, they think the model fits in the MOC. But it doesn't mean that impossible. Maybe in some cases it's working, but better to use PLS. Another thing that we need to consider here. Here is I don't know how you familiar with the name Hair, Hair. This one is one person that is very famous in the statistics of management. He mentioned that he doing one research, and in this research he tried to compare the result of PLS and SEM, PLS and CBSEM. So the same model, the same data, he compared the results. And few times he conducted this research with different models, with different data, and the conclusion that he gets is when the sample size is large, means more than 300, if your sample size is large, mostly the result of PLS and CBSEM is same. So we shouldn't be worried about that. So if our sample size is large, CBSEM and PLSM is going to be same. But when our sample size is few, definitely CBSEM, PLSM is better compared to the CBSEM. So this is the things that this is the justification that you need to come up when you want to select in your thesis, or your students want to select the PLS or CBSEM, they need to come up with this type of justification why they selected the software. And you see, we say that CBSEM is more in theory testing, but PLS is more in the prediction, means exploring some things. But still, they can use also, in some cases, PLS also can be used for theory testing. It doesn't mean PLS cannot be used for theory testing. It can be used, but if other conditions like sample size is large, the number of variables is not so many, better to use CBSEM for theory testing. But if I want even test the theory, but my sample is new, better to move to PLS. Another thing is that we need to be familiar with the sum board. We call PLS model a structural model. We have the name latent variable. In the regression, we just call variable. But here, any unobserved variable we call latent variable. Just this term we use in the PLS and CV7. And the relationship between unobserved variable we call a structural model. So testing the hypothesis. The structural model is the section that we want to test the hypothesis. Measurement model is the item, the questionnaire side. So later we need to do first measurement analysis section, then we move to a structural section. So we need to be familiar with the term. For example, in the PLS software, the small PLS software, they use this type of name: inner model, outer model. Outer model means measurement model. Inner model means the structural model. This one. So, and the outer model we use when we want to analyze the measurement model. So outer model is equal to measurement model, and the structural model is equal to inner model. So this one is only the aim of this slide is you become familiar with the terms that we use in the PLS.
What about the moderator, the column when
We call all of them is latent variable, only latent variable. So another name that we need to see in the next slide is exogenous construct and endogenous. Endogenous is the variable that another variable can be effect on that. So we call endogenous. So in the PLS we don't use the name moderator, mediator, independent variable, we don't use the name. We just call the two type of variable. The variable is exogenous or endogenous. Endogenous is the variable that another variable will be effect on that. And exogenous is the variable like IV. They are independent and no other variable will be effect on this variable. So this one we call endogenous because there are another variable that will be effect on this variable. But this too is exogenous. Why? Because there is no variable that will be effect on them. There is no other variable that effect on them. So mediator and dependent variable in the PLS we call endogenous. And control variable, moderator, and independent variable we call exogenous. Okay. So moderator, independent variable, and control variable we call exogenous because there are no other variables that effect on them. And dependent variable and mediator we call endogenous. Just this one is the terms that maybe later in the paper you saw the terms and you become confused. What does it mean? Another thing that is very important that you become familiar with is the type of measurement. We have formative and reflective. Another use of PLS is this one. PLS is the only software that can be analyzed formative. But reflective PLS can, regression also can, and CV7 also can. But CV7 and regression cannot analyze formative type of variable. You want to measure, I develop two variables, one variable in two ways. One time in the reflective method, one time in the formative method. So you see what is the difference between formative and reflective. I say that I want to measure a store image. I want to measure a store image. I come up with three variables. One of the variable that is the product is superior products. The product is economic products, and product is reliable products. If you look at the meaning of these three variables, the meaning of these three items, the meaning of these three items is very, very, very close to each other. Economy, reliable, superior. So if the product is economy, definitely the product will be superior for the customer. If the product is reliable, definitely the product is superior for the customer. So because there is the relationship between the items. So the item is interrelated. We have high correlation between the items. Yeah, the arrows is coming from the variable to this one. It means that this one, because of that we got reflective. In the software when we draw in this way. So what is the difference now? The difference in the store image, in the reflective, first we come in with the definition of a store image. First we have definition. Based on the definition, I develop the items. So definitely the correlation between my item, the relationship between my item is very high. But how about here? I want to measure a store image. I'm looking at the item is car parking, facility, glamour. All of these things or the behavior of the retailer, the seller, all of these things is different from each other. And if I remove one item, maybe I miss the meaning of this variable. So it's not easy to remove one item when we have formatting. So what we say that in the reflective, first we have the variable, that the variable make my items. But in the formative, I have first item, and based on the item, I will define the variable. So the interesting thing is, here they come up with the difference with the reflective and formative, but the interesting thing is this one. The Jarvis in 2003 shows that majority of the papers that supposed to use the formative, they use reflective in the wrong way. So the result is not the trustable result, and they just search the journals that is published in the Q1 journals, the paper that is published in the Q1 journals. So you just imagine, even you just see that even in the Q1 journals, we publish many papers that is in the analysis they totally analyze wrongly. So this is the things that they consider. Many of the reviewer will be sensitive of consider reflective or formative. If your variable is formative, you need to consider as a formative is reflective. And the way that you can find that is that you're looking at your items and you see that the meaning of item is close to each other or not. If close, you need to do reflective. If the meaning of item is so far from each other, and the items make your variable definition, you need to consider formatting. And the analysis for these two variables is totally different. And here, yesterday we discussed about reliability and validity. So now when we want to do analysis, the first step is to look at that you correctly measure the variable. So if I'm wrongly measure the variable, later, for example, I want to measure brand image, but through my items, I not measure exactly the brand image, I measure another things. So later, when I find the relationship is the relationship between that variable, not brand image, because I'm wrongly measure brand image. So become significance or not significance, the result is not correct. Because I'm not correctly measure the variable. Just around 1 month ago, one of my friends take the minor correction from review managerial correction. So the paper, everything is done. When I go through the paper, when I reach to the items, I see that totally the item is wrongly measured the variable. So based on my opinion, the reviewer didn't ask for changing the item, but I told him I don't want to be included in this paper because later, yeah, it's for my name because when the paper will be published and the end of my life, I cannot, remove this paper because they cannot change this type of things. So I don't want this ISI paper because I know that the variable is not correctly measure the variable. When I look at the items, you want to measure the performance, but when I look at the item is not measure the performance. So when you wrongly measure the variable, the whole of the analysis will be wrong. So the first things that we need to do in the analysis, we check the validity and reliability. So in the PLS, there are some rules for the validity and reliability. Data you receive for reliability, we have CR. I don't know to what extent you are familiar with the Chromebook Alpha. You know Chromebook Alpha? Chromebook Alpha is used in the SPSS to measure the reliability. Yeah, in the for measure the Chromebook the reliability in the SPSS we use Chromebook Alpha. Here we also have Chromebook Alpha, but we no more use Chromebook Alpha. We use CR. What is the reason? Because Chromebook Alpha is not accurate. Why? Because if you have only two items for one variable, it's very, very, very difficult to take reliability through SPSS, through Chromebook Alpha. It means that Chromebook Alpha is highly related to the number of items. So this assumption is wrong. So the number of items shouldn't be effect on the reliability. So this is the reason we moved to CR. We no more using the Chromebook Alpha, and the software will give you Chromebook Alpha because some of the people prefer to report also Chromebook Alpha. But in none of my papers I report Chromebook Alpha. I just report CR for reliability. Before I'm telling that, if I want give the one example of why we say that the measuring the variable is very important. We say that if you want to, for example, see the effect of one word on the behavior of the people. Okay? If you say to the ink, I want to see the effect of one word on the behavior of the person that is the language is English and the British people and the Iranian people. If I tell them go, definitely they will just moving to somewhere else, some place. So if you use the word go, they will moving. And if you say this word to Iranian, maybe they fight with you because the word have the bad meaning for them. So what is the conclusion? At the end, you will say that the Iranian is like the white, it's not a calm people or something like that, but your conclusion is wrong because the meaning of this word in these two countries is totally different. So the important thing is to check when you even adopt the questionnaire, even you adopt the questionnaire from others, you need to still check the validity and reliability because this questionnaire is tested already in US. And maybe if you test this questionnaire in Malaysia, you cannot reach the validity and reliability because the factor for them and here may be different. So this is the reason we say even you take the item from others, we need to check the validity and reliability. And there are just some terms that you need to check the CR more than 0.7. You just need to remember this number, more than 0.7. The factor loading, more than 0.4. So later, when we analyze in the software, we show that the software will give you all of this number, and you just need to know that this number should be more than 0.4, that number more than 0.7. And ABE is coming to check the convergent validity is more than 0.5. Let me give you a big idea about what is the factor loading and what is later we see the discriminant validity. What is the difference of convergent validity and discriminant validity? In your questionnaire for brand image, here in my questionnaire, I have 3 items. The first things that I need to prove, I need to show that this item is belong to this variable. What should I do? The factor loading should be more than 0.4. If the factor loading is more than 0.4, it means that this item is belong to this variable. If less than that, it means that the item is not belong to this variable. So I need to remove the item. So this one is convergent validity. So it means that I want to show that the item is belong to the variable. But we have another term we call discriminant validity. Discriminant validity means I want to show that this item is not related to another variable. Maybe the item can be in my variable, but two of my variable, the meaning is very close. So the item also can be in another variable in the same framework. So it means that I have brand image and store image. So one of my item, maybe I designed them in the way that I designed the item can be even be in this variable, even can be in the store image. So what should I do? I need to remove that item. And discriminant validity, the aim of discriminant validity is to show me that the item is not belong to another variable. It's only belongs to this variable. So there is difference between convergent validity and discriminant validity. Convergent validity is showing that the item is belong to this variable. And discriminant validity showing that this item is not belong to another variable. So, and confirm that this item, these two terms together show me that the item is only belong to this variable. So, this is one thing that you need only to know, but if even you don't know about the terms, later you need just to check the value. The CR should be more than 0.7. The reflective indicator for more than 0.4, it means that the factor loading more than 0.4, and the AVE is more than 0.5. Average variance excited. And for discriminant validity, there are 2 rules that later in the analysis I will show you how they will show that the item is not belong to another value. This one, when the result is coming, I will show you. But the assessment of formative measurement is different. I don't think today we can cover totally formative, but I will tell you that the way that we check for the reliability we don't have in the formative variables. We just have validity in this one, and the things that the way that we show that the item is belong to the variable is different from the reflective one. But as majority of the papers that I think all of my papers till now I just have one format. So majority of the papers is reflective. So if you know reflective, I believe you can do your analysis in the TLS. So here now we check validity and reliability. We call this one as first step. What we do in the first step, we check the validity and reliability, and we prove that the item is belong to the variable and correctly measure the variable. So the second step is I want to go in and test my hypothesis. That one we call a structural model. Before I'm doing the structural model, we need to show that the model is fit. One of the things that the one that doing the quantitative analysis is very familiar with is R square. R square means if I have two variables that effect on this variable, R square showing that the variance in this result, to what extent can be predicted by these two variables. For example, if my R square is become 0.25, it means 25% my model is successfully can be predicted in the future. So very important are showing that to what extent my model can be successfully predict the results. So if my R square is become 25%, it means only 25% I can predict. But they come up with some rule of thumb. They say if R square is more than 2%, the R square we consider as a weak. If more than 13% is moderate, more than 26% is substantial. But here mentioned, we cannot come up with any number because R square is highly dependent to the context of the study. If you are doing the type of a study in the psychological type of a study, there are maybe 1,000 factors that can affect on my behavior or something. So, but in my framework, I cannot consider all of them. So, I'm expected the R square will be very low. When we go to the customer in the market, the reason that the customer purchase one products maybe maximum is 10%. They consider the price, they consider the service, they consider the quality, something like that. So the factor that will effect on them is not so much. So in the marketing, we expect a very high R square. So it depends to the what type of a study you do. So if in the paper or in the thesis we want to justify the R square, what should we do? We cannot go through any of these numbers. The way that we do, we look at the papers in the same field. If I do intention to purchase in the marketing, I look at the other papers and I see the R square of other papers and compare the R square with my own R square. And I say majority of them, the R square is around 50 to 70%, and my R square is 65%, for example, so it's acceptable. But you just imagine if other paper R square is 80%, and suddenly your R square is 10%. It means that your model is not a good model. So the good model is the model that the R square is close to the previous type of the studies, not very far from the R square of them. I will repeat this. When you check R square, the R square of your study you should compare with the same type of a study in that others do, but the type of a study is same. Means that you do intention to purchase. You just check that the papers that have intention to purchase as a PV, how much is the R square, and compare the R square with your own. Shouldn't be so much difference. If there is many difference, means that there is something wrong. Your model is not different. So this is the way that you justify. I never use this type of number, but Cohen coming with this, but Hay mentioned that for each industry we need to come up with their own R square. Another thing is F square. This one we call effect size. Effect size, it means that they show that to what extent this variable will be effect on another variable. So the F square showing the power of effect. If the F square of one variable is very high, it means that this variable is highly important and highly significant effect on it. So if the F square is above 2%, we call it small. Above 50%, is medium and above 35% is large. And very, very difficult to find the 35%. If 35%, it means this variable is very, very important in predicting another variable. So it means that, for example, if this one, the f square later the software show is 36%, it means that this factor is very important to show the intention to purchase. So if brand image f square is become 35, 36, it means that brand image is very, very important in the behavior of customer to purchase the products. So this term is also they use to show that to what extent the variable that you are selected is a good variable. If the f square of all of our variable is very few, it means that my variable is not a good variable for this framework. But if f square is high or at least more than 2%, it shows that the variable is a good variable. Another method they use is blindfolding. We show this one also, and the blindfolding should be the Q2 should be positive. The software will give you all of this result, and you just need to know that the Q2 should be positive. Here is we are talking about mediator. The things that we have here, one of the another use of PLS is normality of data. Regression and MOS have the assumption that the data is normal, but PLS don't have this assumption. What does it mean? When you give the questionnaire 1 to 5, 1 to 5, the PLS has the MOS have the assumption that the data is completely normal. Yeah, the normality assumption is in the regression and the PLS. In the regression and the MOS, CBSEM. But majority of the times, my data is not normal. For example, the data is something like this. So the normality assumption is not a good assumption. And this is the reason that we say that for almost the data should be a big data. Because when your data is very big, we can become close to the normality assumption. But with the 100 data, never we reach to the normality assumption. So this is the reason that we say that for the MOS, the data should be big data. So the normality assumption in many cases we cannot reach. And if the data is not normal, the PLS, the MOS and regression have very high bias. So this is the reason that we say that we use the PLS, because PLS don't care about the normal. Another thing, on the mediator, last time we used the formula for if you want to test the mediator, we use the Boron and Kenny formula. Based on the criteria of Boron and Kenny. Boron and Kenny is the name of two others. And the funny thing is, from 1986 to 2010, all of the researchers used the Boron and Kenny when they want to test a mediator. And in 2010, the Boron himself mentioned that the assumption that we have in the Boron and Kenny from 1986 is totally wrong. So it means that 24 years we test the mediator wrongly. We mistake, and now we understand that the assumption that we testing now is not correct. I will explain what is the assumption was. Last time, if you want to test the mediator, first you will check the IB on dependent variable relationship. First, you need to show that this two is significant. This one is significant. If significance, then you will move to add mediator to the framework. So the first assumption is IB on dependent variable should be significance. But this one is the assumption that is totally wrong. The IB on DV no need to be significance. So this one, last time, if it's not significant, they won't go to test the mediator. But now we say that this one is not important at all. So it can be significance, can be insignificance, but the mediator can be still existed. But they say how? Because around 5 years ago, many papers discussed on this issue, and some of them say we need to test, some of them say we don't need to test. And at the end, they come with the conclusion, no need to test. What is the reason they say need to test? The ones that say that no need to test, they say that if IB have no effect on DB, so how can I say that IB have effect on DB through some another variable? Itself don't have effect, so no need to test. So they said mediating cannot be exist because IB don't have any effect on DB. But at the end, they say that you just imagine I have two mediators here. One of the mediator is positively effect on DB. Another one is negatively effect. It means that here is positive, this one is positive, negative, totally become negative. So negatively effect, positively effect. And these two effects, positive and negative, come together, become no effect. In some case, positive, so it means that there is positive effect plus negative effect. So at the end, is no effect. So this is, they say that can be two mediator, through one mediator is positive, through another mediator is negative, and at the end, IB on DB is no effect. So this is the reason we say that no need to test IB on DB, and till only even till now we can see in some papers they test through Boron and Gini. And if you go just to his own website, the Boron website, he has their own website. You go to the website, he mentioned that this assumption is not correct. So C is not important for me to be significance. I just want to be A significance, B significance, and A multiplied to B significance. This is another three assumption that we have last time. And now we test this one through bootstrapping. So for testing the mediating, now we use bootstrapping. And using, what does it mean, bootstrapping? Another also benefit of PLS is bootstrapping. But no SPSS also adding bootstrapping. What is the problem? In the last time, if your sample is 150, you just imagine you have one sample 150. You want to analyze, you analyze one times, and you calculate A, you calculate B, and you calculate C, you total of your data. But bootstrapping, doing another way. In the bootstrapping, we select how many times we want, and they say that more than 500 should be. We put that, please do 500 bootstrapping, and the software doing subsample from my sample. From 150 sample, get 500 times subsample, and the subsample one time is 100, another subsample is 110, another time many subsamples. The software will get from 500 times. The software did subsample and test the analyze, and 500 times calculate this A. 500 times calculate this A, and at the end take the mean. And they show that the result of bootstrapping is more accurate compared to only analyze one time with the whole of the data. So they analyze the model 500 majority or you put 2000. Since my model is the software take 2000 sample from my data and analyze and at the end is there. So the coefficient will be very accurate. So another things that you need to know that is that p-value show you that at the end that your hypothesis is significant or not. Correct? So I think majority of you here is that the p-value should be less than 5% to be significant. But how we calculate p-value? You remember I told you y equal to alpha 1 a1 plus alpha 2 a2 plus error. So in this model, this is a1, this one is a2, this one is alpha 1, this one is alpha 2, and this one is y. So I want to predict y. Y is equal to alpha 1 multiplied to a1 plus a2 multiplied to alpha 2 plus some error. So these two, alpha 1 and alpha 2, we call that coefficient. We call this one as hat coefficient. Right? So t value is equal to hat coefficient divided to a standard error, a standard deviation, or a standard error. Same one. So t value will be calculated by dividing this alpha to a standard error. And there is one table, if you check in the Google, you just say p-value table. Based on the p-value, you can find the p-value. So the p-value is calculated based on the p-value. And that's all. So the things that is important here is I want to mention, I want to discuss on that is the standard error. The reason that we say that your sample should be not small sample is a standard error, a standard deviation. Why? Because when your sample is only few 30 to 50 samples, your standard deviation is very, very large. Become very large. And if this one is become very large, the t-value become low, and the chance of become significance is become less. So you reject the hypothesis only because of your sample. Because increasing the number of samples not so much effect on the fat coefficient. By increasing the number of your samples, the standard error will be changed. And if you increase the sample, the standard error become less, and definitely p-value become more. So yesterday I mentioned to you that the sample shouldn't be very small, and even the sample shouldn't be very large. This is the reason. If the sample is very small, your standard deviation is become large standard deviation and t-value is become less, and you have error 2. Error 2 means you reject the hypothesis that is should be accepted. Supposed to be accepted, but because your sample is very small sample, you reject. So, and if your sample is very, very large, 1,000 data you collect, your standard deviation is become very, very small. And t-value going up. And all of your hypotheses will be accepted. And then you accept all the hypotheses, and actually we call this one an error too. You accepted some things that's supposed to be rejected. Why you accepted? Because your sample is very large. So please don't think that the big sample, very big sample, it means that you work harder. The sample have rule of thumbs, and we need to keep in the mind that the sample should be maximum 500. Please never collect more than 500 data. 500 is the maximum. Then the minimum you can find through the table that we discussed yesterday. There is a table, you check in the table how many population you